Welcome to our new unit, Chapter 6, Linear Functions. Before we start with today's lesson, I do want to take a quick note of the word linear. So our unit here, linear, essentially means a straight line. So what we're looking at here in this entire unit is we're going to look at graphs that have a straight line graph. So they are called linear functions. There's a bunch of things we need to be able to do when we look at a straight line graph. First one is called slope. So today's lesson, 6.1, is all about the slope of a line. So when you look at a graph, when you look at real life, you can see slopes in many different places. You can look at it as ramps, if you ever built a ramp to jump your bike off of. Look at a gradual slope of a hill, or if you actually are looking at a mathematical graph, you can look at the slope of the angle of the line. Slope is simply a mathematical formula used to describe the steepness of a line. Is it very, very steep, or is it a little more flatter? A higher number for your slope would indicate a straighter or more vertical slope line. A lower number would indicate a more flatter slope. Slope can be basically described as the rise over the run. And that's what we usually say. What's my rise? What's my run? Let's divide the two. Our rise is literally our vertical distance. How high do we go? And run is literally our horizontal difference. How far do we go across? So rise divided by run. Now there is a mathematical formula we're also going to use, and it's listed right here. K is the mathematical constant for slope. So when you see K, you got to think slope. And our very famous formula is y2 minus y1 divided by x2 minus x1. If I'm on a graph, just sketch one here real quick, and I have any particular point, it's going to have coordinates. It's going to have a x value and a y value. The x is literally where it crosses the x-axis, so I don't know, maybe this is at 3. And the y is where it literally crosses the y-axis. Maybe this is at 1. So every single point on our graph can be determined by an x and a y coordinate. Now, in order to find slope, we need to know the x and the y coordinates for 2 points, point 1 and point 2. So let's see how we actually would attempt to determine the slope of a line from a graph. So my steps. So determine the x and the y coordinates from 2 points that fall on your line. Now we're going to talk about what is a good point to choose and what is a less good point to choose. But any 2 points that do fall on the line will work to get your slope. Now to make our life a little bit easier, we're going to say that our first point is going to be our furthest point to the left on our graph. And our second point will be the furthest point to the right on our graph. Now in reality it doesn't actually matter, but to make our life easier, let's kind of have this general rule. Point 1's to the left, point 2 is the one on the right. We're going to figure out the x and the y coordinates for both these points, plug them into our formula, and then we can solve. So example 1. Determine the slope of the following line. So first thing we have to do is choose 2 points. Now here's our lovely line. We can choose any points that fall on this line to calculate slope. But like I said, some points are better than others. If you look at your box of your graph paper, so any one of these boxes kind of blown out, if you can find a point that crosses the corner of the boxes, they're much better points to use. If we have a box and our line kind of comes through something like this, well, now we're really kind of estimating exactly what this value is. if you go to a graph, every line here is going to be one value. 1, 2, 3, 4, 5, and etc. So if this is point 0, we know this corner of the graph falls at the 1. If this is 0 and this is 1, where exactly does this hit? Well, is it 2/3? Is it a half? Is it a quarter? There's a little bit of guesswork. So it's really nice to get the corner of our box to fall through our line to make sure we know the exact value of it. So now let's choose my 2 points. Which ones are nice to use? I think this one right here hits my corner pretty nicely. And that doesn't really do it for me. I don't like that. Right there is pretty good. So I'm going to use these 2 points as my 2 points to determine slope. So now I label them point 1 and point 2. We set the most left point, which is this one, is point 1. And the most right point will be point 2. So now I want to kind of set up a little table here that allows me to pull off my information really nice. I've got point 1, I've got point 2, and I'm going to put a little x, and I'm going to put a little y. And I'm going to find out what is the x and y coordinates for point 1. I'm going to switch colors here. So where does this cross the x-axis? So here's my x-axis going across. It comes down. If I draw a line directly to the x-axis, it's going to hit it at 0. So for point 1, the x value is 0. For point 1, where does it cross the y-axis? Well, this one's really nice because it lands on the y-axis, and that's 0, -1, -2. So the coordinate points for point 1 would be 0 and -2. Let's do the same thing now for point 2. The x and the y coordinates. Well, where would point 2 cross the x? I come down and it would cross it at 1. Where would it cross the y? You draw a line to the y, and it would cross it at +2. So the coordinate points for point 2 are 1 and 2. Put that into my little chart here. Now this allows me to plug these numbers into my slope formula very, very easy. So my slope formula says that my slope, k, is going to be the y value of point 2. So here's the y value of point 2, which will be +2. And I'm going to subtract the y value from point 1. Well, here's point 1. Here's the y value of point 1. I'm going to subtract -2. I'm going to divide this by the x coordinate from point 2. X point 2 is 1. Subtract the x coordinate from point number 1, which is 0. So now 2 minus -2. When I think subtracting negatives seem like adding, so I can read this as 2 plus 2. So 2 plus 2 is 4. 1 minus 0 is 1. 4 divided by 1. My slope is 4. So what this means is that I'm going to go up 4 values for every 1 I go across. Up 4 on the y for every 1 on the x will give me my slope of the line. Okay, so now we looked at this in terms of determining the slope from a line on our graph. We can now extend this and say, okay, we no longer have an actual graph, but we just have these points that we're told. Here's point S, here's point T. What is the slope of the line without using the graph? So I start out by writing my formula. K equals y2 minus y1 divided by x2 minus x1. Now, which point is going to be first? Which point is going to be second? Well, I don't know, but this first one is listed first, so I'm going to call this 1. And I'm going to call this 2. Now I need to figure out what is my x and what is my y value. In a point system here, coordinate points, the x is always first, y is always second. X is always first, y is always second. So feel free to actually write this out as much as you like. As much information as you want, make sure you write it down so you don't forget anything. When you get better at this, you may be able to simply look at this and say, okay, well, there's point 1, there's point 2, I know this is x, no, this is y. But when we're first starting out, let's actually write this down to remind ourselves. Now we go back to our slope. The y value from point 2, well, I called this point 2. There's the y value, 4. Minus the y value from point 1. Well, there's the y value, so it's negative 7. Put that negative in brackets. Divided by the x coordinate from point 2. Well, that's negative 3. Subtract the x coordinate from point 1, which is 5. So now I've got 4 minus negative 7. Same as adding, 4 plus 7 is 11. Divided by negative 3, subtract 5. I'm 3 to the negatives. I'm going to go 5 more to the negatives. That's negative 8. So I have a slope of 11 over negative 8. Now I am going to rewrite this so that my negative sign is attached to both denominator and numerator. So I have negative 11 over 8. When I look at slope, I always like to have my change in my x value as positive. So I would read this as I would go down 11 values on my y-axis as I go to the right 8 values. So to figure out the slope from 2 points, just take them, label 1, label 2, get the x, get the y's, plug them in, and then get your answer. Finally, let's take a look at giving some slopes and then drawing the lines from them. So I'm going to start by looking at drawing a line segment with the following slopes. Now technically, the line that I'm going to draw could be drawn anywhere on the page. So you need a starting point. So this particular question doesn't give you a starting point. So I'm going to use the origin, 0, 0, as my starting point. I'm going to put a little dot there. Now I look at question A, and the slope is 3 over 2. So what that means is as I go up 3 on my y-axis, I'm going to go across 2 on the x. So my origin is my starting point. I'm going to go up 3, 1, 2, 3, and then across 2. I'm going to get right there. There's my second point. So up 3 and across 2. I'm now going to draw a line between the two dots. Put my ruler on dot 1. Oh, what happened there? Let's try it again. Put my ruler on dot 1. And draw it up to dot 2. I'm going to make that a little bit darker for you. I'm also going to extend it down in this direction as well. So there's my line from A, and I'm going to label it with an A. Now I'm going to go with question B. I'm going to change colors on you. Let's just go to a red. And my slope is -1/4. Which means I'm going to go down 1 on the y, and I'm going to go across 4 on the x. So again, I need a starting point. Again, I'm going to use the origin, just because I like using the origin. I'm going to go down 1 and across 4. There's my dot right there, 1 and 4. Take my line, and connect the dots. Change that to a red so it fits in, make it a little thicker. And I'm going to extend this in both directions. And label it B. So I've got starting point, I went down 1, across 4, and then made a nice straight line with my ruler. So here we looked at slope, getting it from a graph, example 1, getting the slope from 2 random points we're told about, example 2, and then example 3, taking the slope and reproducing the graph. Let's now go to our textbook. We can work on page 339. Let's do 4 questions from the A's, 4 from the B's, and make sure we try 1 of our C's.